Okay, so today what we are going to be doing is we're going to be modeling direct variation. And direct variation is a relationship in which the ratio of the two variables is constant. So as the x value increases, then the y value is going to be increasing. Or on the flip side, if the x value decreases, the y value also decreases. So a linear equation is a direct variation if it's in the form of y equals mx. Normally you have y equals mx plus b, but we want the b to actually be 0 here. We want the equation to pass through the origin. So if it's y equals mx plus nothing, you're good. A direct variation is a line whose y-intercept is always 0. Okay? So what happens here is if you take a look at the first equation here, to tell whether it represents a direct variation, you want to get it into, at least in this first equation, get it into y equals mx. And if we can get it as a direct variation, we can identify the constant of variation or the slope, which means if you add x to both sides, this equation equals y equals x plus 4. Well, the fact that we have a y-intercept that's not 0, this is not going to be a direct variation. All direct variations, y-intercepts have to be 0. Because we're looking for the constant of variation, if the variation is constant, if the slope is constant, then you have a direct variation. Slope is always y over x. So if I take a look at the y over x, this becomes a fourth because 4 over 16 is a fourth. 5/20ths is a fourth. 6/24ths is a fourth. And 7/28ths is a fourth. We do have a constant of variation. So what's happening here is y equals 1/4 x. And the scale factor, the constant of variation happens to be a fourth. Alrighty. If you take a look at this next one, graph the direct variation. Well, you already know it's direct variation. Y equals negative 3x plus 0, right? Because all direct variations begin at the origin. And then my slope, I'm going to go down 3 to the right 1, down 3 to the right 1. And there's my direct variation equation I passed through the origin. This one that also passes through the origin, if I find my slope, I'm going up 6 to the right 1. So my slope is 6 over 1, and my equation is going to be y equals 6x. You can put plus 0 if you'd like. It's not necessary, but you can put it. The cost of cookies y varies directly with the number of cookies bought, which is x. The cafeteria sells 3 cookies for 75 cents. We're at a direct variation equation that relates x and y. Well, let's find the constant of variation. Let's find the slope. And where the slope is going to be, in this case, the cost per one cookie. So if it takes 75 cents for 3 cookies, then it costs 25 cents for 1 cookie. So the cost that you're going to pay in the cafeteria equals 0.25x. Remember, if you buy no cookies, you don't spend any money. So how much do 8 cookies cost? Well, y equals 0.25x, and that's going to be 8. That gets substituted in. My 8 cookies are going to cost me $2. Given that y varies directly with x and x is 14 when y equals 7, write a direct variation equation that relates x and y. Well, again, we've got to find the constant of variation or the slope. So we know that it's going to be y over x. So y is 7 when x is 14. So that simplifies to a half. So now we know that our equation is going to be y equals 1/2 x. If y varies directly with x and y is 15 when x is 10, then what is y when x is 6? Well, again, let's find our constant of variation, or y over x. We know that y is 15 when x is 10, and if you simplify that, you're going to get 3/2. So your direct variation equation is y equals 3/2 x. Well, we want to know what y is when x is 6. So y equals 3/2 times 6. Well, 3/2 is 6. 3 times 6 is 18. 18 divided by 2 is 9. So we know that y will be 9 when x is 6. Okay, so that's it. Good luck on the homework.